So we're going to be presenting how we all collaborated in creating the sustainable house. I was in charge of making sure that we had a correct or like a good building. So we all decided to choose a student residence because that's what we're all going to be going into next year.
Collectively, we decided that our environment would be the West Coast, and my role in this was to make sure that as we went through this project, that all of our resources were easily attainable to the environment.
So we started off by coming up with a list of issues and goals we wanted to consider. For example, we want our material to be sustainably sourced and to have a low impact on the ecosystem around it. We wanted the building structure to also incorporate thermal control and regulation in both the summer and the winter without using any energy. And we also wanted the energy to be renewable with no emissions and have a low impact on the local ecosystems.
So Tracy and I were in charge of chemistry, Heather and Nancy were in charge of biology, and Martin and Andy were in charge of physics. We closely discussed about each of our systems and how they interrelated. Andy's system required no energy. Martin and Tracy's stored renewable energy, which was used to pump water through my filtration system, which Heather was able to use and reuse the water that was filtered and distributed throughout the house, including watering Nancy's vertical garden.
So I basically collected everyone's information. I was able to summarize it and put it into the poster.
We also wanted to provide visual aid. Therefore, we created additional diagrams on the poster to better understand our ideas.
I researched ways we can create sustainable energy sources. So instead of using lithium-ion batteries to support our electronics today, we can use recycled materials to create them instead. A researcher in Germany actually extracted organic compounds from apples to create sodium-ion batteries. And these batteries are way more sustainable and they're available at low cost.
To generate renewable energy for our building, we're using electrostatic wind energy converters. These work by spraying positively charged water particles in the presence of wind from an insulated container, leaving behind excess of negative charge. Electrostatic wind energy converters have no moving parts and thus do not produce noise, vibrations, and other issues associated with traditional wind turbines.
The water filtration system that we use is a carbon block filter. This is made using coconut shells, and coconut shells are a renewable resource. The filtration is done by a chemical process called absorption, where the coconut shells contain many micropores which are able to trap the contaminants from the water. This can remove particles down to 1 micron.
Grey water is all domestic wastewater from household appliances and usually contains dust and grease. The grey water recycling plumbing system is a double pipe drainage system that runs throughout the home. It uses grey water from showers and washing machines, which is then filtered and used for kitchen sinks, dishwasher, toilets, and gardens.
By using bioconcrete which traps rainwater, this can allow for moss to grow on the outside of the building, creating a vertical garden. Not only does bioconcrete create a beautiful exterior, it can also absorb carbon dioxide, which filters the air to make a healthier environment. In addition, it can also insulate heat by absorbing solar radiation, which regulates the heat inside the building.
When wind hits the building, it creates a pressure difference. Air will flow from higher pressure to lower pressure. Windows can be opened in the direction of the wind, and this creates a natural ventilation system. The temperature difference between the interior and exterior allows for buoyancy-driven ventilation. Since warmer air is lighter than colder air, warmer air will leave through the upper windows and colder air will enter through the lower windows.